Hello, everyone. My name is Jan. I'm from Slovenia. We're switching to English, so I hope that everybody will understand. Thank you for having me here. When I discussed with Carlos me coming here, he asked me, Jan, would you like to present on something? And I said, well, I have nothing new. And he said, well, then, can you present something interesting for the operators? And I thought that we did not talk about the best kind of operational practice for the operators here in this region yet. So who in this room is the operator and is deploying IPv6 for the end users? Hands up. Yep. Okay. The others are following, I hope. So, how did this thing happen? So here we will be talking about a document that we wrote in the RIPE community. This document actually discusses the main issues related to the operational practices when deploying IPv6. We need to understand that making wrong choices when deploying IPv6 for the ISP may have some negative implications on your deployment. If you deploy it wrongly, then after some time, if you feel that you didn't do it properly, you need to get back, roll back your deployment, and this may cost you a lot of time and lots of money. So, me previously working also for the Internet Society, I was traveling around the world talking to operators, helping them deploying IPv6. And when I heard the pattern, the question that came up quite often, then we decided that this is a question that people need answers to, and we started writing a document how to do it. So in this particular document, so these are co-authors. This is not just me writing something, how people should do it. These are people from as you can see, these are people from various operators from Slovenian Telecom, Mark Townsley from Cisco, Andrew Alston from Liquid Telecom, Gert, Jordi also helped with this. Jen Linkovac is now the six-man co-chair at the ITF. Luis, he's usually here from Brazil, but he's not this time. Hi, Luis, if you are watching. Kevin Manuel for ISOC and Lee Howard, he was at Retevia back then. So this is quite a good team of people that put together their experience while deploying IPv6. So this is the table of content. What did we discuss here? So usually what I get as a question from the operators is, what is the size of the prefix delegation that we should assign to end users, right? To enterprises or to normal end users, not commercial. And here we went into this discussion and described why something between /56 and /48 makes sense. Then we went into how to number the one link between the CPE and the operator. And then we set prefix assignment options like /48 for everybody, 48 for business customers, /56 for residential customers, or prefixes longer than /56, why it's not a wise idea to give people a smaller prefix than /56. And then the part that was actually the most, how to say, controversial was how do we assign prefixes, statically or dynamically? I know that operators usually go with IPv4 mindset says, oh, dynamically you just give the end user one IP and then if the CP reboots, you give them another and everything is fine. With IPv6, this doesn't work, period. If you go and change the prefix to the CPE when the CPE reboots, or you deliberately change the prefix, current technology does not support this. because this means flash renumbering, and that user needs to renumber all the devices behind the CPE. There is no net. And this brings problems. I will talk about this a little bit later. So, a generic set of recommendations if you are deploying IPv6. IPv6 is not the same as IPv4. In IPv4, we are counting addresses. We are counting the number of IPs in prefix. In IPv6, each prefix has its own meaning. Like /64 is the smallest one that you can put on one layer 3 network. That's basically your LAN side on your CP router at home. /56 means prefix to the end site, or /48 means a prefix to the end site. When you are planning and when you are doing your addressing plan, don't be very conservative, but also don't be very liberal. What I see with the operators is usually they go and make the addressing plan, and they put everything in the very first small part of the assigned space, and then they figure out they can't upgrade anything because they run out of space in that little space that they used. Then they throw it away. Second version is usually way too big. They waste all the space and basically run out of space before even deploying it. So the third version is usually something in the middle, and that makes sense for the real use. And on the other hand, if you need more IPv6 space, you can always go back to your RIR and ask for more space. If you want a simple addressing plan, go for /48 for each customers. This is the simplest one. It's on the nibble boundary, and you can actually, your customer can play with 4 characters in a hex code between the nibbles. If you decide to be conservative and give /56 to each customer, then people need to make sure that they understand how to do the addressing plan on their side, how to divide the network, because they cannot play with all the characters in between the nibbles. We also heard people arguing that they are giving /48 to the business customers and /56 to the home users, just to differentiate based on a marketing sales level, so that the business customers has a feeling that they are getting more because they are paying more than a home user. It is all fine. Whatever you do in between /48 and between /56, everything is fine. Everything is technically feasible. Going lower than /56, it's not recommended. There is a specific case for cellular phones, because for the PDP context, they usually assign /64, but that's 3GPP specific stuff and out of the context of this document. We also get lots of questions about how to number the WAN links, the links between the CPE and the operator. Our generic advice is use the numbered links, because with unnumbered links you can get into some sort of trouble. Some people argue unnumbered links are more safe, but we say for the troubleshooting purposes, put some global unicast addresses on both sides. If you want to use a /127, that's advisable, but then allocate a /64 for each link and just use the first part out of it. This has proven as a really good practice in real life. Okay, now let's address the elephant in the room. who of you deploying IPv6 here are doing the dynamic prefixes, are changing prefixes every time? Anyone? Don't do that. Try not to do that. It is very well described in the document why this is a really bad idea. In short, basically this is what happened to many people, also to Fernando, had problems when the ISP changes the prefix. But this is a story from Africa. Andrew Alston, Liquid Telecom, they deployed IPv6, and I was helping him with stuff, and I told him, go static, please go static. And he was like, nah, I will figure it out. And he went dynamic. After some time, he calls me and says, Jan, Google put me on the blacklist. They put us on the list of the poorly deployed poor IPv6 deployments. Why? Then I explained to him, well, if somebody has a laptop at home, for example in Kenya, power outage, CPE reboots, you have on that laptop, you have the IP address from the old prefix. When the CPE comes back, it receives a different prefix, and the CPE doesn't know what prefix had before because it's not persistent across reboot. So the CPE happily starts advertising the new prefix, but on your laptop, you still have the old IPv6 address that has 1 month of time of lifetime, and preferred time is 1 week by the standard. And this laptop is still using that IP address to send out traffic because that's a perfectly valid IPv6 address. And then that means that if that laptop tries to connect to Google, and they are measuring this actually, you send a SYN packet. They send back SYN ACK. Your packet will come out of the ISP's network because of default routes and will come to Google. They send SYN ACK back, but the packet will never make it back because there is no backwards route anymore because that prefix is not active anymore. And they expect ACK packet back from you. You know, it's SYN ACK, ACK. And when they never get the ACK packet back, they're measuring it. And they say, okay, this is a broken IPv6 implementation. And they actually stop serving IPv6 traffic to you. This is how you actually kill your IPv6 connectivity at home. So for example, for whoever I helped deploy IPv6 at the operators, I told them, look, just go static. You will receive so much less calls to your help desk that it's not even funny anymore. For example, Telekom of Slovenia, they actually put the prefixes in the radius database next to a user because they're doing PPPoE. And when there is the authentication, the AAA, also the system gets fixed prefix for that user. It doesn't matter where they are. So they made it that fixed, and they have no problems whatsoever. So now with Fernando and I and Richard and Jen are working on the RFC to basically change the timers from 1 month to something that makes sense actually. So Fernando, we are at what now, timers? 1 hour and 45 minutes. Yeah, we are at 1 hour and 45 minutes as a preferred. Yeah. So we are trying to change the defaults in the IPv6 specification, but that doesn't solve your original problem because IPv6 were never meant to be to dynamically change the the prefixes. So my advice is don't. Go static. Don't complicate your IPv6 deployment, please. Please don't do this. This is not something that is very, very useful. Acknowledgements, there was lots of people contributing to this document. There were lots of discussion. This document got a very, very solid consensus in the RIPE IPv6 working group and in the best kind of operational practices task force. And it is widely used, at least in our region, for the operators how to think about IPv6. Where to find the documentation? You can find it here. It's free. Download it, read it, think about it. If you have any questions, I'm around, or you can send me an email. And yeah, please, I don't have the Babel fish here. Can you ask in English, please? Thank you.
Hello. This document is very interesting and very full of details and interesting reading. But one thing that I fail to understand every time I look is the /48 for everyone. It doesn't make sense to me. I really want to understand what's the reasoning behind it, because I see for a corporate customers the usage, but not for a broadband users. Like, in which situation the /48 will be used in a broadband scenario, for example?
Well, if you decide to give people /48, you can. It's basically up to your brain. If you can't live with the idea that you are wasting IPv6 space, then don't do it. Then give them /56.
No, I understand that. I'm just trying to understand the reasoning when the document was produced. If there is some use case, it's not about saving IPv6, but just trying to understand the reasoning where this idea came up. If there is any real usage that I'm failing to see.
Well, some people want to have in their routing table just /48s.
Okay.
Right? They go like, okay, if I have different sizes, it hurts my OCD. It basically comes down to that. It's purely the personal preference. Even /56 would be more than enough for the business customer. So it's like the biggest reason that I heard was that actually people gave 56 for home users and 48 for business customers to create a differentiation in sort of like to make business people more proud, they get more. Like, but technically it doesn't make any difference.
Thank you.
Thank you.
Jordi Palet. There are many other reasons for the /48. We have discussed that many times already. But the first one is you don't want to be ultra conservative in IPv6 if we know that IPv6 will last at least for the next 500 years. But that's a different problem. I just want to say that I already talked with Jan, and we had a discussion in ITF V6 Ops a few weeks ago, and we are aiming, probably I will publish it next week, this document becoming also, hopefully, a BCP in ITF.
Thank you very much. Any other question?
¿Alguna pregunta más?
Everything is clear, apparently. Thank you. Happy deployment of IPv6.
Thank you, Ian. Un aplauso.
Thank you, Ian.